Hello everyone. Good evening. Good evening once again. Today we will talk about data recovery strategies, and also we will see what strategies we have in data warehouse called Snowflake, or we call data intelligence platform. And in today's world, we all know that these industries, organizations, their lifeline is data. They extract insights out of the data, and strategic decisions are taken out of the data, forecasting the numbers, predicting the future. All these insights happens based out of data. And we are already seeing the live examples like product recommendation, or even if you try to chat or email, it will recommend what based upon your previous chat. All these are some live examples we already see. And this data is like a fuel, and saving it is very important, and also recovering it is even more important. We will look into some data recovery strategies already industry experts uses. One famous is backup, and very old popular method is taking backups of your databases or storages. It is like you are photocopying a document and keeping the copy in another drawer. And when, in case of accidental deletion, or you have any compliance issues and other factors, you will get it. But this is slow process, and also you have to take a backup of entire systems. And further, incremental and differential backups came. That means rather than taking backup of the entire system, you can decide what data you want to take backup, the latest data. Differential backups from the last backup time to the current time, whatever changes that has happened, you can take that backup. But the recovery time is very slow for these backups. And one more backup strategy we have is taking snapshots. Yes, these snapshots are good, but they consume lot of space. You have to, let's say, taking daily snapshots or something from where you can recover your data. It's like cloning your database. It's like taking a screenshot of your system, and whenever you want restore that, you can instantly do that. Let's say 15 minutes ago I have taken a screenshot of what I am doing, and on that point I want to recover it. Yes, I can recover it on that time by taking the snapshot. Okay, backup snapshots, they are consuming lot of space. And also recovery time is slow. Still, people are using backups and snapshots in terms of like to be more redundant and resilient. Taking a backup in another region, and taking a snapshot every day, that helps to maintain the data or the databases in a more resilient way. Now coming to versioning, that is storing the multiple version of your data or history. Let us say you are taking versions. Whenever a change is made, you are also saving the old version. A new row has been added into the table. You have the current version and also the old version of the table, and also previous version and that previous version. And it is a very good in terms of recovering the data, especially human errors, accidental deletions, entries, misinterpreted values that has entered into the table. All these things you can go back and correct it by getting the old version table, old version document. But the problem is version sprawl. If every table after changes, it saves the old data and also the current version, that means old version of the table and the current version. It leads to something called as version sprawl, which is saving too many versions for the same table. When compared with the actual storage, what you're saving and what you are saving in the underlying storage, there will be a huge difference, which reflects higher storage costs. That is one drawback we have in versioning. Okay, now coming to time travel. See, this is recovering, going back and recovering the historical state. And for this time travel, you should version your tables. See, 15 minutes back, like whatever the status of the data is there, I want that particular table. I have deleted few rows, some inserts happened. I want to go back and get that 15 minutes back table or previous days table or couple of days table. Then that is called as time travel. For this, versioning is very important. When you save multiple versions, you can time travel and get the data. And one more method for this data recovery is erasure coding. And when especially data is saved in files or in tables based out of distributed environment like Hadoop, data is distributed on multiple computers. You can compare it with like there is a puzzle. Data is like a puzzle and it's split it into pieces, and these pieces are distributed across multiple systems. And how, let's say, one or two systems they got crashed and they are experiencing downtime, how we can recover the data? That is erasure coding. This is like taking backup only. In backup, what we are doing, the latest data or the whole data we will take backup and save in a different system. In erasure coding, we are doing the same thing, but we are splitting the table into chunks, right? And these chunks has a parity codes. You can come for now, you can like relate these chunks with pieces in the puzzle, right? Let us say there is some 6 rows in the table, just for understanding purpose. Rather than taking backup of 6 rows, actually when the data got saved, how it got saved in the distributed environment. 2 pieces here, 2 rows here, 2 rows here, 2 rows here. And again that puzzle will be rearranged. How? Using this parity code. Parity code is like an instruction that tells how to rearrange the puzzle. Suppose if this server number 2 or machine number 2 is experiencing downtime and those 2 rows are not available for us. They're unavailable. Now what can we do? We can recover only those 2 rows instead of 6 rows. Why we have also taken the backup of that chunk, only that piece of chunk. When I want to recover, I'll recover only that chunk, not all 6. That is erasure coding, planning the or taking backup data in chunks and also using this parity codes. Replication, synchronizing or asynchronizing the copies. Like you create a replica for your database, whatever changes that will happen to your database will be replicated to another database or to another table. That is replication. These are some strategies. Let me clear up this. Yes. Now we understood that there are different strategies for data recovery. Now let us also look into the steps. First, assess data. What is the criticality of the data? How important is that data? Then what is the volume, change rate? Accordingly, you will choose one of this. If change rate is very high, versioning maybe you can do. And you have to be cautious clearing the old versions. Suppose the data is not changing at very rapid pace, then you can take backup once in a day or once in an hour, or take a snapshot. Assess the data first. How critical is that data? And volume and how fast it's changing. And accordingly, define your recovery point and time. So how you can add your recovery points and time? Like every 5 minutes, you will take a snapshot. From that snapshot, you can recover data in case of data loss. Decide on how, upon your changing rate, decide this point in time recovery. Choose the strategy. Based on the requirements, choose one of these strategy. Implement, deploy and automate. Every time you should not go and take backup or a snapshot or a replication. Any of this strategy which you deploy, that has to be implemented further automatically. And then test and monitor it. Regular validation, whether things are working fine or not. And if you want to especially deploy and automate these strategies on premises, it requires a lot of infrastructure and maintenance. And that is where choosing clouds has many advantage. Clouds like AWS, Azure, GCP, we already have. But coming to data intelligence clouds like Databricks, Snowflake, they offer very interesting features, especially to recover your data. We will see them. You can seamlessly plan this strategies. Okay, we already talked about these strategies: backups, snapshots, versioning, replication. Out of all this, time travel and cloning, especially when you are managing data in tables, accidental inserts happened or accidental delete happened to the table, you can immediately time travel and get back to your old version. Cloning, you can clone your tables time to time on a schedule basis. Accidental deletions, you can restore, already you have a copy, you can restore. And we have something called as zero cloning. Not only restoring the data, without actually creating a physical copy, you can use zero copy cloning in Snowflake. We will discuss about them. And industry best practices. 3:2, 3:1 rule. Maintain 3 copies of data and 2 different storage types. Like one as file and one copy as table. With 1 copy offsite again. Again in 3 copies, it's better to maintain 1 copy offsite, especially when data is very crucial. And again, depending upon how critical is that data, you will plan this rule. Define clear RPOs and RTOs, that is point in recovery points and recovery times. Automate everything, regular testing, document the procedures, maintain detailed runbooks, and secure, like encrypting your data and making your data immutable. All these are the best practices. Now coming to Snowflake, see, we have a comparison here. Industries recovery economics. Already industries are suffering from data breach. Around $4.44 million decline over 5 years, and ransomware downtime. 35% of data from many industries is permanently lost. And cost per record, right? And there is a universal risk. So planning recovery strategies is very, very important. Now coming to clouds like Snowflake, they have made this recovering or like time travel, different ways of data recovery strategies you can plan seamlessly on this cloud. Like for example, in Snowflake, they have something called as time travel. In time travel, for example, you see this is your current data. 2 rows you have inserted into a table. After day, these changes, like this is your current version. This is version 1, 2, 3, and 4. Anyways, we will go back like this. Now, today, this is your data. You have made some changes. You have updated a row. You have inserted a row in your table. This is current day. Now, after 90 days, I want to go and get the old version. I don't want this updated row now. I don't want this inserted row now. I want that old version table. So I'll let us say if it is more than 90 days, I cannot do anything. I cannot time travel. Up to 90 days, time travel is possible in Snowflake. Okay, let us say I have made changes. Next day, I want to recover the old table. It is possible. After 7 days also it's possible. After 30 days also it's possible. See, the recovery time will increase. But after 90 days, yeah, you cannot get it. And after 90 days, you have something called as fail safe. Let us go here. Fail safe is an additional 7 days protection layer. Even after that 90 days time, up to 7 days, you have a chance to recover your old version of the table. And how? By contacting the Snowflake. Failsafe is it's like Snowflake's feature, but you cannot implement it. It's like an emergency recovery. Snowflake support only. Whereas time travel, you have user access. For standard Snowflake, it's 1 day only. For licensed Snowflake, like production Snowflake, up to 90 days, they were giving you a beautiful feature called time travel. Whenever you want to go back and restore your old versions of data, yes, you can do that. Zero copy cloning. This is one more feature from the Snowflake where you can seamlessly clone the database, especially for development and testing, rather than giving access of your original database. It is always better to clone the database. And when you clone the database, actually another physical copy is not created. Instead, it will only create a reference. You can assume something like original database is something you are writing on paper. And when you want to create a copy, rather than separately writing the same word or same phrase on a different place on the paper, using a different ink, you are overwriting it on the original database. So in that way, there is this another feature of Snowflake called as zero copy cloning. Instant database copies and without any duplication. And with these features, you can save up to 95% of storage. Like whenever you want a copy, you need not worry about the storage. Instant creation and perfect for testing. And again, it depends. When only for development and testing, you can clone and work with the tables. In production environment, when it's actually needed, you can create a physical copy. And due to these features, Snowflake excels in data recovery. Zero copy cloning. You will create instant database copies without duplicating data, especially for testing and development environments. If any mishaps happen also, you have your database, right? Original database. And also here you are storing the, you're saving up on the storage cost up to 95% by zero copy cloning. And 90-day time travel. This is an excellent feature in terms of data recovery. Up to 90 days, whatever changes you have made, if you want to drop them and get the old uh, data of yours, you can get that. Fail-safe protection. And after 90 days time also, up to 7 days, recovery is possible by contacting the Snowflake. Because of this, cost optimization, you need not bother about taking backups or snapshots. Let us say you will take backup of your tables, but not snapshots, because already they are providing point in time recovery through the 90-day time travel. Now you can, no need to plan snapshots or replications. Just once in a day, take a backup of your table. So other costs, obviously, the snapshot costs, the replication costs, all these will be optimized. Up to 75% of the cost will be reduced. Now you only have to manage your backups. And also further, you need not bother about how to plan your point in time recovery. Point in time recovery means when you want to travel back and get data, at what point, every 5 minutes or every 10 minutes, every 15 minutes, you take a snapshot of your table. So at what point you can travel back and restore the data. Now already Snowflake is doing for this job for us. We need not bother about that. Instant recovery. Even the whole table is got deleted. They have a command called undrop. Within 90 days, in standard editions 1 day, anytime you can say undrop command on your table, you will restore your table. And changes happen to your table, anyway you can use the time travel feature. And Snowflake also replicates your data across multiple regions. And one more feature of the Snowflake is it is also compatible with multiple clouds. And Snowflake level, you have a multi-region replication. And also these cloud vendors like AWS, Azure, GCP, you can attach them with Snowflake. And at your cloud level also, you can plan multi-region replication. All these advantages we have. Built-in recovery, so no separate infrastructure is needed. Automatic continuous protection, no manual backup scheduling is needed. You can do it continuously automatically. Instant recovery with time travel. So no need to restore the large databases, no need to take snapshot time to time. Query in any historical point easily. But in traditional methods, you have to do lot of planning to achieve this point in time recovery. Like you want to figure out the right point in time recovery. High storage costs for multiple copies. Here, you can do the zero copy clones, especially in dev and production. You need not put your data separately as a physical copy. Difficult to test recovery procedures. Here it is easy without affecting the production. And to manage the recovery, you need special infrastructure, special teams. Now here it is not required. Simple SQL commands are enough. And that makes huge impact on businesses, right? All recoveries. And also you are optimizing the cost, storage. Okay. And here I have some insights. Like which are some collected from sources. Like for example, in Verizon data breach report, they say that data loss costs businesses an average of 7,900 per minute, according to this particular blog or article. and Fortune 20 healthcare. They have saved a lot of money. A Fortune managed healthcare company successfully retired 2 mainframe systems. And they have transferred this 212 terabyte across multiple formats. And they saved a lot. They say that after moving the data to cloud like Snowflake. Like this, there are more insights. Now let us also look into the hands-on, how we can use these features of the Snowflake. I'll go to the Snowflake account. I already opened the notebook. I have created, let me show you, stage already, Snowflake manage stage. And in that stage, I have uploaded the data also. And where I can show you that without, yes, here. Just load data into table or load files into a stage. I am bringing file, so I'll click on this. All I have to choose is select the database. Wholesale DB, I already created this. And here I also created schema and then stage. Now I'll browse, select data and upload, which I have already done. Now on using this data, we will discuss these features, time travel features of Snowflake. First, I'm setting context to my notebook or worksheet. You just click on this plus icon, you will get an option. There you choose SQL worksheet. And here first thing you have to do is, if you have not created any data warehouse, create it. If you have already created, just say use the demo warehouse. I'm saying create and replace this demo warehouse. First thing. And after creating this warehouse, I'm saying create the database wholesale DB and schema init raw data. These I have already created, so it will replace it. Create or replace the stage wholesale stage. You can also do it manually, or through code also you can create or replace the stage wholesale stage. I'm going to bring the CSV file. So I'm creating the file format, just mentioning that I'm going to use the CSV file. Type is CSV file, field optionally enclosed by quotations. And skip header equal to 1. Okay. Then create target table. Here skip header equal to 1 skips the header. Because you are creating this table here, it uses these names. So we are skipping the header. And I'm creating the target table. Here I'm going to load the data. Run this again. Now loading the data. First I'll check whether data is there, because even though I already have the data, I have used this create or replace the stage wholesale stage. So I'll go and check whether data or a file is there in this stage or not. Stage is nothing but storage. Yes, the query produced no results. Now I'll go and add data again. Browse. Select this file, open, and select the path, wholesale DB, raw data schema, and select the stage, wholesale stage, upload. Okay, files are uploaded. Now I'll come back. List the files from the stage called wholesale stage. Yes. Now you can see the file I have uploaded. Now this CSV file I am copying into the table I have created here. Copy command, copy into customers table. Run. And while copying, file format also we are giving. Type is CSV. and other details. And let us observe how many number of rows are there in this customer table. 440. And also view data. Out of 440 rows, we are selecting 10 and you can see those 10 rows. First 10 rows. Now let us delete. Delete from customer table where channel is equal to 1. You have channel numbers here, right? And we are deleting all the rows which are having channel number 1. Run this. See, now 400 and plus around 440 rows has been dropped to this number 298. I want to count, already we counted this. Now I want to restore the tables or sorry, not tables, rows which I deleted. So what I'll do, query the table as it was 60 seconds ago. I want that old data. It was not 60 seconds ago, maybe just now I have ran it. You can make it as 30 seconds, 50 seconds, 1 hour as you want. And this is nothing but the time travel feature. It's you to mention the time in minutes or in seconds. And we are saying offset is greater than equal to minus 60. That means around 60 seconds back. Whatever rows are available in the table, we want that. Okay, run this. Okay, how it is showing only 142. Okay, run again. From customer table at offset, let us say 300 seconds. Before 300 seconds. The requested time is either beyond because I created the table just now. So let us give any other 200 or 200 is good, I think. Yes, 440. So like this, you can query your old version of the table. Now suppose not rows, if entire table is dropped, drop table customers. Let us cross verify the same. Show tables like customers. No table. Now I can instantly restore it using undrop. And we restored the table. Let us cross verify. See? And when I deleted, I have deleted few rows already. This is the old version of the table. The current version is having only 142 rows. The time when I deleted the current version and I restored it. Drop and undrop. Deleted and restored. Let us update. I am applying 50% discount on this fresh column. Okay, I'll check the modified data. Average fresh after update. I'm calculating the average. before update, I just want to compare a quick comparison. This is before the discount. I mean, after discount, sorry guys, after discount. And now I am going to run. This query gives you average price before discount. I'm going back to the old version, that is 60 seconds ago, around 1 minute ago. From there, I am calculating the average. Restore using clone. Okay, up to this point, we only we only queried the old version of the table. If I want to get back it, not permanently, not as like one more physical table, I just want a copy for a while. So I'm going to create a clone of my old version. I'm not going to copy it as another physical table. What clone is doing, it is like a overwrite you are doing, right? You are creating an index. Create or replace the table, clone. At offset greater than equal to minus 60. That means around 60 seconds ago, we have a old table version. We want to restore it. Restore it as a clone. Now every time I need not bother about this time now. Because I created a clone, I created an index on that particular version. I can directly use this name without mentioning any offset. Otherwise, every time I have to calculate the offset as time ticks. I should calculate like how long it has been I have made the changes, and accordingly you have to give this offset. If rather than that, you want that old version of table for a while, yes, then you can restore it as a clone and work with it, right? Because the old version, after applying the discount, that is last 60 seconds ago, we have the same table. Suppose if I say 200 seconds ago, then see, I have the old averages before discount. Now you can know the query history also. Just you have to use this information schema and get the query history. Like when delete happened, update happened, drop happened. Every time, rather than calculating this offset, if you know the particular timestamp, when delete happened, when update happened, or when drop happened, accordingly you can make use of that timestamp. Instead of roughly giving some numbers, you can also give the exact timestamp. Let us run this. Yep, sorry. And you can see when the start time happened. And table name equal to customers. So you can also get the information schema. And you see the table type base table is transient no. Here it's just giving the information. See last altered values. You know the last altered value. zero copy cloning. Now again, I'm using the zero copy cloning. Validate the clone. Okay, and I can also add dates, like, I can increase this. Not only seconds, we can also give days and hours like this. Okay, this is how you use time travel features. Thank you.